Okay, now the last two questions on here are either we do x, vi, vf, a, and t. That is, we have to solve for something. And specifically, we're going to solve for the acceleration and then do f equals ma. Or sometimes we do this and find the acceleration and solve for something else, right? Now the first one here, we know that we've got rest, from rest, so that's initial velocity 0, 38 meters per second, that's the final. And 0.985 meters, that's our x, right? And we have three quantities there, right? Also, because it's asking for the force, we don't have the force, so we can't find the acceleration. So definitely we're going to solve this thing first, and then we're going to do f equals ma, right? So I want a, and I want to use a formula that has no t, so I'll use vf squared is vi squared plus 2ax, right? So 38 squared equals 0 squared plus 2 times a times 0.985. Okay, so I'm going to do this. I'm going to go 38 squared, right? And then I'm going to go divided by 2, divided by 0.985. And I get, wow, that's a lot of acceleration. Is that right? Wow, that is. Okay, so my acceleration is 732.995 meters per second squared. I'm almost done. Normally we'd be done, but we're not done yet, right? So now we got to use F equals ma, right? So force equals 0.145 kilograms times, and then we're just finding the net force, right? So 732.995 meters per second squared. Okay, so I'm just going to take what's on my calculator and go times 0.145. I get 106.28. All right, which is about 106 with 3 digits. Okay, so that's what this one is. So just look at it. If I give you the force and the mass, then it is that you find the acceleration and do one of these. If it is that you know 3 kinematic quantities, and I'm asking you for the force, right? Then it is that you do this and then do F equals ma. That's kind of the way it works.